Hi everyone, welcome to this new lecture of fluid mechanics. In this lecture, we'll discuss a problem on water hammer in pipes. So in our previous video lectures, we have already discussed so many things regarding the water hammer in pipes, how this water hammer will be created when the flowing in the pipe, and what other regions may arise, or what are the points need to be considered when water hammer in pipes is created, like a sudden closure of valves when the pipe is rigid, and sudden closure of valves when the pipe is elastic, and a gradual closure of valves. So all the things we have discussed in the theory part, and we have derived some formula also for that. So based on that, let's solve a problem here. So the question given here: water is flowing through a velocity of 1.5 meter per second in a pipe of length 2500 meter and a diameter 500 millimeter. At the end of the pipe, a valve is provided. What is the rise? What is the rise in pressure if the valve is closed in 25 seconds? And take the value of C equal to 1460 meter per second. Let's consider the valve is closed in 2 seconds. Find the pressure rise behind the valve. Assume the pipe is to be rigid and consider bulk modulus of water K equal to 19.62 into 10 to the power 4 Newton per centimeter square. So this is the question given. In this question, actually two things need to be identified when the valve is closed within 25 seconds, and another one is when the valve is closed in 2 seconds. And for this only we need to find out the pressure rise. We need to find out the pressure rise in the water, and here also we need to find out the pressure rise behind the valve, and by assuming the pipe is to be rigid. So this is the another condition actually, and consider the bulk modulus of water equal to this value is given. Anyway, so for this, let's start the problem here. So we can write first one. We can write the data given here. So here, if you see the data, so starting from the first line, like here velocity is given. So let me write here velocity equal to 1.5 meter per second, and second one is the length given. So length equal to, you can write 2500 meter, and the diameter of the pipe is given. So d equal to 500 millimeter. So you can convert it into meter. So this can be written 0.5 meter. Okay. Now, what is the time is given? We need to first condition is there. What is the rise in pressure if the valve is closed in time 25 seconds? So here we'll write this is the time is there. So time equal to 25 seconds. And consider the value of C. So C is nothing but the velocity in the pressure rise when it is valve is closed. So C equal to given 1460. So you can write this is 1460 meter per second. So what I told that C value equal to the velocity of pressure rise when the valve is closed. Now here we can consider that P equal to rise in pressure. P equal to rise in pressure. When the pressure will rise when the valve will be closed, and there will be a high pressure wave will be formed in the back end of the valve. So here we need to find out the pressure actually. So we know that for this condition we can say the pressure equal to, we have derived the formula P equal to rho LV by T. Rho LV by T. Now we need to first find out that is the T is satisfied the condition or not. Like I'll tell you, this formula can be used only when we need to consider that valve is closed gradually or valve is closed suddenly. So for that condition we need to first satisfy the condition of T. So that means let me tell you. So for that condition is actually here we can write, we know the ratio. The ratio in the sense, we can write the ratio of 2L by C. 2L by C. So this is 2L by C, what I'll tell you. This is the actual ratio to identify whether the valve is closed suddenly and whether the valve is closed gradually. So ratio is there. Let me find out first this value. So 2L by C is nothing but 2 into L equal to 2500. Length is there pipe, and this is 1460. So finally we can get the value. Let's solve it here. So 2 into 2500 equal to divided by 1460. So 3.42. So here we can write 3.42. Okay, so this is the time taken. This is the time taken. So we know that the T is greater than 2L by C. That means the valve is gradually closed. The valve is, you can write, gradually closed. If this is the that means what the value of T is greater than 2L by C, then the valve is gradually closed. If the T is less than this one, then it is suddenly closed. Like that we need to consider. Now here if you see T value, how much is given? T value is 25 seconds, and which is greater than the 3.42 second. So obviously this condition is satisfied for this one. Okay, so this is the condition what I told you, that we need to satisfy this. T greater than 12 by C. Now for gradually closure valve, okay, the rise in pressure equal to, now we can use this formula. Okay, if the formula was different, like the T value is less than this 2L by C, then the valve is closed suddenly. So for that, pressure value will be different. So now we can use this formula, that is P equal to rho LV by T. So rho equal to 1000 and L equal to 2500, and this is V. So velocity 1.5 meter per second, and divided by T. T is nothing but 25 seconds. So this is the value of pressure. Now if you calculate this, we can get the value, like let's see, 1000 into 2500 into 1.5 whole total divided by 25 seconds. So this is 1,50,000. So 1,50,000 Newton per meter square. So this one we can write here. This is the pressure value here. Now 1,50,000 Newton per meter square. The same thing we can write here. You can convert this one into in terms of Newton per centimeter square also if you want. So that will be nothing but 15 Newton per centimeter square. So this is the pressure rise when the valve is closed within 25 seconds. This is our first condition, and this is the rise in pressure. Okay, so this is our answer, we can say. Now in the second condition, if you see, for the second condition, let's solve it here. So second condition, what is given? Here time is given. Here if you see, the time is given 2 seconds, and we need to consider the valve, that pipe is rigid. So here we need to consider the pipe is rigid, not elastic. And similarly, we need to consider the bulk modulus of water, that is K equal to 19.62 into 10 to the power 4 Newton per centimeter square. Now this one we can convert into Newton per meter square. So we can write here, this is 19.62 into 10 to the power 8 Newton per meter square. Now here also we need to find out the value of rise in pressure. So this is also depends, like condition is here, what condition is pipe is need to be rigid. Okay, and for this condition, what is the pressure equation? So again here also we need to consider this like this value, this T equal to, we need to satisfy this condition. So for that, here actually our C value already already C value is given here. 1460 is given here. Now for this condition actually we need to find out the C value. So here to identify the C value actually, which is known as that, as I told you, the velocity of pressure in the wave. So here we need to calculate C value. So C equal to, we can write the formula actually K by rho. So K by rho we can write, this is root over of 19.62 into 10 to the power 8, and the value of rho is nothing but 1000. So if you see here, this one we can, root over of this whole one, we can do it. Let's calculate this, how much we'll get. Let's see. So 19.62 into 10 to the power 8, 10 to the power, let's put 8. So we'll get this one, okay, and divided by 1000, and root over of this. So we'll get 1400.71 something will get. So I'll take it 61. I'll take it here. So here I can write, this is 1401, not 61, 1401. This is meter per second, because this is the velocity of pressure in the wave. Now we need to find out again the ratio that we need to satisfy whether T is greater than 2L by C or T less than 2L by C. So we need to satisfy this one. So we need to find out the value of 2L by C. So 2L by C we can calculate here. So 2 into our length of the pipe is given 2500. So there we can find out what is the value of so L equal to how much is there, 2500 as I told you. So you can write 2500 and divided by the C value 1401. Now again let's calculate this. So this is 2 into 2500 and divided by 1401. So 3.568. So this also we can write here 3.57. So this is the time taken. Now here if you see, our valve is here closed at the time of 2 seconds. So now what I can say, now here the T is less than, so 2L by C. For this condition we need to use the formula of pressure is different here. Now the pressure rise for this condition, we need to consider P equal to V into root over of K into rho. So this is the formula of pressure rise when T is less than 2L by C. So here also again same thing, just we'll put the value of all these things, then we can find this value. So velocity value 1.5 is given and root over of this K value is 19.62 into 10 to the power 8 and rho value is 1000. So now if you solve this one, you can get the value of pressure. So let me find out the pressure value, how much it is coming. So 19.62 into 10 to the power 8. Okay, this is root over of this, yeah, and multiply of 1.5. So this is 16,000 something is coming. Okay, no, this is 19.62 into 10 to the power 8 is there, again 1000 multiply need to be done. So again we'll do 19.62 into 10 to the power 8, okay, into 1000 again. So root over of this, so root over of this is equal to 1400, so 14 lakhs, again multiply 1.5. So yeah, now we are getting 21 lakh 71. So this is in terms of Newton per meter given, meter square given. So this one we can write here, this one we can write here, how many, 210100071 is there. So this one we can write 21 or 210 into 10 to the power 4. So this one we can write 210 into 10 to the power 4. This is Newton per meter square. And similarly, we can write this also. This is if you want to convert into centimeter square, only you can write 210, and some point will be there, fraction value. So this one, suppose 1. So this one we can write Newton per, this is centimeter square. So both are correct. So this is our required answer. So I hope you understand the conditions what is given and what you need to calculate. So this is two different conditions we have taken here in this same question. One is when the pipe is normal, and another one is the pipe is rigid. And for that we need to find out this conditions, that T is greater than 12 by C and T is less than 12 by C. Based on that only we can use the this formula, P equal to rho LV by T, or this is P equal to V into root over of K into rho. I hope you understand the problem. Still, if you are having any doubt regarding this, you can give a comment on the comment box. Thank you all.